What's up, team? Today we're talking arcs and central angles. So let's dive right in. Central angle. That's an angle with a vertex at the center of a circle, and its sides are radii of that circle. So here we go. We have this circle. It's named X, and angle AXB is a central angle because its vertex is at X. And that's all it is. It's just some angle with the vertex in the center of the circle. In this case, AX and XB, those are both radii of that circle, so of course they're going to be congruent. One kind of cool thing about these central angles is they're always going to form essentially a isosceles triangle. So if you're looking to figure out some angle measures here, you can figure that out. Okay, that's it for that. We're going to use that circle, though, as we talk about the minor arc and the major arc. We've discussed these briefly before, so I'm going to kind of zoom through it. The minor arc, that's the shortest distance between 2 points on a circle. So in this case, if we were interested in talking about this distance between A and B on the circle, we would say that is the measure of arc AB. Measure of arc AB. Or if we don't actually know the measure, we just want to talk about the arc in general, we just say that's arc AB. If there's only 2 letters, it's the minor arc. It's the shortest distance between the 2 points. To contrast that, the major arc, that's the longer distance between the 2 points. So that's if you go the long way around. So to talk about that, we throw in a third point. In this case, it's C, and that tells us, hey, we're not going the short way, we're actually going the long way. So if we talk about ACB with that arc symbol above it, this is referring to the long way from A to B, whereas arc AB is the short way from A to B. So there's some definition, and here's some notation that's super important. All right, example. Circle C has diameters of JR and KQ. Pause. Circle C, I did not put that in there. So C is the name of the circle. Diameter JR, diameter KQ. Cool, let's keep going. The measure of angle RCQ is 50 degrees. Let's find that. RCQ is 50 degrees. Super. Find the following. Oh gosh, we need to find the measure of this arc and all this type of stuff. So, fun thing about arc measures and central angles is that their measures are identical. So in this case, we know that angle RCQ is 50 degrees. Therefore, the measure of minor arc QR is also 50 degrees. So let's capture that right there. So again, this central angle is 50 degrees, so the minor arc is also 50 degrees. Okay, let's look at some more stuff here. The measure of arc JQ, that is this chunk right here. And the way we're going to do that is we know that JR is a diameter. Diameters chop a circle in half. So the arc JR would be 180 degrees. We don't want the whole thing. We just want J to Q, and we know that this is 50. So we'll just do 180 minus 50, giving us 130. So again, this is, where do I put this? Maybe right here. 180 minus 50. Show my work. All right, next one. The measure of angle CRQ. This one's kind of funny because it's sort of like it's not quite a triangle, but it kind of looks like a triangle, and we're going to treat it like a triangle, and I know that's a little awkward. So what I like to do for these is I put like a little dashed line in here. That's for myself. And what's going on here is we know that we have a triangle. We know that it must be isosceles because every radius inside of a circle must have the exact same length. So this and this those are congruent lengths. Therefore, these base angles are also congruent. We know that triangle angles, they all add up to 180. 50 of it's already occupied. These two need to add up to 130. We know that they're the same. 130 divided by 2. Let's put that here. 130 over 2 is 65. So the measure of angle CRQ is 65 degrees. I know that one's a little funky. You may need to chew on that one for a minute. I'm going to keep going though. The measure of arc JQR, I know that this is a major arc because there's 3 letters here. So it's going to be more than 180. I don't know what it is, but it's going to be more than 180. JQR, so it goes from J to Q to R. Well, interestingly enough, I said it was going to be more than 180, but it's going to be exactly 180. That's kind of fun. JR is our radius, so we're measuring this arc here. It goes halfway around the circle, so it's 180 degrees. All right, next, measure of arc JKQ. So this one, I'm feeling better about it being more than 180. J to K all the way to Q. So we're looking at this arc plus this arc plus this arc is what's going on here. Now, there's a few different ways to tackle this. You can find each of these individually. I'm noticing that JR, this whole chunk here is 180. And this chunk here is 50. We did that earlier. In fact, it was given. So just 180 plus 50 is how I'm going to tackle this one. 180 plus 50, and that ends up being 230. So this is a 230-degree major arc. All right, last one is not a trick question, but it's a slightly different type of question. This is asking Arc Jk is congruent to which other arc? Well, Jk is down here, and it's congruent to Arc Qr. Reason being is if you think back to when we studied angles so much, remember vertical angles are always congruent to one another. So if this angle here, QCR, is 50 degrees, then angle KCJ is also 50 degrees, making Arc Jk also 50 degrees. So Arc Jk and Arc QR, or RQ, however you want to write that one, doesn't matter, are congruent to one another. All right, brief overview of arcs, central angles, plus an example. Dive into some practice problems. Let me know if you have questions. You got this.